Welcome back to another video. Today we will take a look at theorem 2.4.8. So we let a, b, q, and r be integers such that a is greater than 0 and b equal to aq plus r. This one is like we have the division algorithm when you consider a and b, where a is the divisor. So you're gonna have b equal aq plus r. Okay. And what is r? R is the remainder of b when a divide b. Then what do we have? What happened to the greatest common divisor of AB? The greatest common divisor of AB will become the greatest common divisor of A and the remainder of B when B is divided by A. For example, you might have to calculate the greatest common divisor of 100 and 125. I think most of you guys can find the greatest common divisor of this one faster, which is 25, right? And then let's use this property. So we know that 125 equal 100 times 1 plus 25. So we divide one of the number by 100 and the remainder is 25. That means that we get to have 125 equal 125. But we divide one of the number by 25. So we divide 100 by 25. So we're going to have 100 equal 25 times 4 plus 0. So the remainder is 0. So right now we're going to have 0 and 25. Right? And that's it. Okay, I think we can find the greatest common divisor, and it turns out to be 25, right? So this is how to use theorem 2.4.8, and then we are going to prove this one. So let's prove it. So we let a, b, q, and r be integers such that a is greater than 0. Okay, and then b equal to aq plus r, where r is greater than or equal to 0 and less than a. Okay, what can we do? We want to show that the greatest common divisor of AB and AR are equal. So we let D be the greatest common divisor of A, B. And the greatest common divisor G, which is A, R. And we try to show that G, D equal G. Okay, so let's take a look at the greatest common divisor of A and B. We start from this. So since D equal to the greatest common divisor of A and B, what happened? So we're gonna have D divide A and D divide B. So from this property, what do we have? I'm trying to use property number 5. Okay, which is if you have A divide the sum of two numbers B, C, and A divide one of the number, which is A divide B, then A will divide another number, in this case A divide C. So take a look at this one here. We have B equal to AQ plus R. And right now we know that D divide A. Okay, so from this right here, what do we have? So we have since D divide A. So it's pretty obvious that D divide AQ, right? Okay, D divide AQ. And then what do we have next? What we have is we have to use theorem. So right now we have D divide B. Okay, D divide B, or I gotta say N. Okay, and B equal AQ plus R. So what do we have here? That means that D divide AQ plus R. And since D divide AQ plus R and D divide AQ, so we use theorem. So theorem 2.3.1, this one here, property number 5. Okay, property number 5 implies that. So what does it implies? Implies that. So it implies that D divide R, right? D divide R. Okay, when D divide R, what happened? When D divide R and D divide base A, D divide A. Okay, that means that D divide the greatest common divisor of A and R. So that means that D divide G. Okay, so since D divide A and D divide R, that means that D divide greatest common divisor of A and R. Okay, then what do we have? D divide G. Alright, so that's what we have right now. We have D divide G. Okay, then let's try to show that G divide D. Alright, let's go. G divide D. So we want to start with G. Okay, so G is the greatest common divisor of AR. What does it mean? That means that G divide A and G divide R. Okay, then what do we have next? The next thing we have is we want to take a look at G. So I want to show that G divide B. Right now we have G divide A, right? That means that when G divide A, G will divide AQ. Okay, since G divide A and G divide when G divide A, we need G divide. So since G divide A, G divide AQ, right? Right now we have G divide AQ and G divide R. Okay, and G divide R. That means that G divide the sum of AQ plus R, right? G divide AQ plus R. That means that G divide B. Okay, why G divide B? Because B equal to AQ plus R. Okay, so now we have G divide B and we have G divide A. What does it mean by this? Since G divide A and G divide B, that means that G divide the greatest common divisor of A and B, and what do we have? G divide D, right? because D is the greatest common divisor of A and B. Right now we have D divide G and G divide D. So from this one right here, what do we have? Since D divide G and G divide D, that means that D equal to G, and therefore the greatest common divisor of AB, which is D, right, equal to G, which is greatest common divisor of AR. Okay, so that's what we have right here, and I think this is one of the most useful theorem in order to calculate the greatest common divisor of two numbers. And that's it for this video.